Yeah, so then, yeah, it's a pleasure to meet everyone. To better understand what we do, I will give you a bit more background on where we're coming from. So my co-founder, Matthias Aufdemer, he's a mechanical engineer, and then developed more into electrical engineering, and lastly worked at Porsche in production optimization. This was yeah, his main task, and there he came into very close contact with vibration monitoring, and was getting in touch with predictive maintenance as well. And he realized that a lot of solutions, especially in the IoT and the sensor field, had a lot of problems to in their current setup. Like, they were very expensive, took a long time to integrate, and also had shortcomings on the software and analytics side. This is what we set out to change with AISight. So to create a very easy to use end-to-end solution comprised of a hardware and a software to predict errors in machines, and basically to reduce unplanned downtime. So this was maybe a quick introduction into what we're doing, and I'll dive a bit deeper inside the problem now. So even now, 20% of total production costs are associated to downtime and inefficiencies. I think there's a big link also to the previous presentation, who's more focusing on the visual inspection. So it's definitely a large problem and a lot of costs associated to this. To give you an idea, just in the automotive sector, 1 hour of breakdown can easily cost up to $2.9 million. This is the problem we are setting out to solve. And to dive a bit deeper into the machines and problems with machines, I'm showing you this slide, which is a bit full, but I'll walk you through it so it's easier to understand. On the one hand, here on top, you have a machine that just vibrates, or it operates over time. And then in the natural course of operating the machine, certain parts, they start to wear, and the machine is starting to have problems at some point. And all these problems in most mechanical machines, they lead to vibration, which is a good measure into detecting if faulty behavior comes or is starting to appear in this machine. So we have on the y-axis here different maintenance approaches that are currently prevalent in the industry. So the very bottom, we have reactive maintenance, which means you run the machine until it fails and then you replace it. So this is done a lot with low acid machines, where you can basically afford to have I don't know, 2-3 spare ones in your shelf. But of course, it's not very efficient, and it can lead to a lot of downtime, especially if the machine is critical in the production line. Then one level above, you have preventive maintenance, which yeah, you also might know on a personal level from your car. So in routine intervals, you inspect it, you check the machine based on own experience or the manufacturer's, the OEM's recommendation. The problem with this approach is that usually it leads to a lot of extra maintenance. So you really want to be safe the machine doesn't fail. So you don't do maintenance according to the real degree of wear of the machine, but you just want to be sure. And everything that happens between two intervals, you also don't understand what's happening there, and a failure can happen here. So then, since a few, almost decades, the whole topic condition-based monitoring came up, where you install sensors to the machine. But usually these systems are not very smart yet, because they operate with fixed thresholds. So in the vibration measurement field, as soon as a vibration goes above a certain threshold, you get an alarm, but there's no further analysis done on what might cause the error or how much time you have left until the machine really fails. So also these systems usually take a very long time to set up. We're talking months, even years here, to calibrate the right thresholds. And then also it usually leads to a lot of false alarms. So the field where we are operating in is actually it's predictive maintenance and machine diagnostics. What does it mean? So over the last 2.5 years, we created a large database of all kinds of machine data, in good states, bad states, and specific error cases we have labeled into our algorithm. So we can now tell if a machine, actually we can tell the root cause of the problem. So not just that there's something wrong, and we can also give an estimate on how much time you have left until the critical failure will happen. And the benefits for the people who are operating this machine is of course that they get a lot more planability in the next into their maintenance schedules. They reduce crisis work. They can already order spare parts, and in the next planned shutdown they can exchange a part, and they are saving a lot of costs that is resulting from unplanned breakdowns. What does the solution look like in the end? I even brought one of the sensors here that we developed. So it's yeah, it fits very well into my hand. I have pretty standard hands as a scale. And at the bottom you see here is a magnet. So you can very easily attach the sensor to any type of machine. And inside is a very high resolution vibration sensor on 3-axis, temperature, magnetic field. And then the communication goes through Wi-Fi. So the sensor sends data through Wi-Fi. How this works is actually, since we have quite some sensors, we do a lot of pre-processing on the edge to reduce the amount of data, and also have we are running some models on the edge to pre-analyze the data. And then we go through either the customer's Wi-Fi or our own LTE gateway to the cloud, where we then run our algorithms, and we also have a dashboard plugged in for visualization of the data. So it's accessible from any kind of device, and I'll show you in a minute what it looks like. So this is a picture from one of our installations. So it's really, really easy to install. You just attach the sensor, you plug in power, and you link it to the Wi-Fi. So the whole setup just takes a few minutes. And then because of this pre-training of the models, directly after the installation, we can already tell you how your machine benchmarks against our database. So we can tell you, for example, in this motor, if there's already a bearing fault or not. And then on top, we run our anomaly detection. So we train the typical behavior of this motor in your production, and then also give out alarms once there's deviations from how we and the software got to know this machine individually. So mainly our core use cases so far are rotating machines. So can be pumps, motors, compressors, gearboxes, bearings, everything that's rotating. We do some more complex use cases, which we are researching at the moment, also together with the Fraunhofer Institute, especially in the areas of injection molding and also CNC spindles. The good thing is that the resolution of the sensor is so high that you can even detect the slightest nuances and deviations. And yeah, this is then what it looks like on our dashboard. So you have an overview of all the systems. It will tell you the condition, and if you zoom in, you can click on any of these cards and you will see the components of this system. So in this case, this filler capper is made up of 12 different motors, components that we are all monitoring, and you will be able to get insights into the trends, temperatures, and at the same time in the background, our anomaly detection and our root cause analysis is running and will alert you through email or SMS if any faults come. This is very useful, especially since maintenance staff a lot of times is very mobile. They're running through the factory, and they need the alerts on their phone because they don't monitor everything in real time. So I already talked about the use cases. We strongly focus on rotating equipment, so pumps, fans, compressors, motors, gearboxes, as I mentioned before. And to give you an idea of our current customer base, so we are working with a lot of companies, especially in Germany and in Europe. Some larger ones are for sure Henkel, Audi, Miele, BASF, the Frankfurt Airport, and DHL Express, and also Gerolsteiner. What you can see is that there's not a strong industry focus because we focus a lot on rotating equipment, which is very common in across many different industries. So this is to our attraction. Then the team, we are 18 people now, from all kinds of backgrounds, mainly in data science and software, but also in electrical engineering and mechanical engineering, and then of course marketing and sales. And to talk a little bit about our traction, so we started in July 2018. We were part of the HEX accelerator, which is a US-based accelerator. We spent some time in Shenzhen with them to develop the hardware. We then spent the second part of the program in San Francisco, where we did our fundraising for Series Seed, which happened in October 2019. We made the Forbes 30 under 30 in March 20, and we're now on track to raise our 10 million Series A towards the end of the quarter. So yeah, if you are interested to invest, or like the company before us, we're also looking for talent always. And of course, if there's some interesting use cases you have in your own production, this would be very, very interesting. So I'm happy to discuss this after the pitch. So thanks a lot. Pleasure to meet you all, and I'm looking forward to any questions.